watch out for that, and watch out for node.js modules in Rust from Peter.
Yay. So I'm here, and I'm here to talk about fast and safe native modules in Node.js. And actually, it's a case study, is how people call it. I just call it my story, because this is my story how I actually started working on something rusty. I've been looking forward to this thing for a long time. I've been like poking around the project. I've been checking out when the Rust book came out. I started reading it, but it's been so long time since then, and I haven't found the real use case. And we've been discussing in the breaks that right now, not many people can afford to start a project over and like just write some things from scratch. So that is why Rust is a super cool language, because you can just write a module and expose it into your existing platform, existing language, and then call it from that. We're going to see how I did it. So it's me. You can find me on Twitter and on GitHub. And I work for a company that's logo is over there, Rising Stack. We work with Node.js, which is kind of invisible here. But so what I do is how I describe it. I build stuff on the internet that I can't show my mom because it's invisible. I'm a back-end engineer, mostly working on infrastructure. And I work with this lovely language that we've heard so much about today. Well, you know how it works. And some more. I'll stop bashing it in a few seconds. So it's not a story about JavaScript or Node.js, but it's a story about how I hit the wall once with Node.js. It's not actually me how I hit the wall, but something like that. So we've been working on a monitoring product, which you know, application monitoring is kind of a hard issue to solve because we have like processes that we have to watch and how they work, how they operate, and then they, in our specific example, they report it once every minute, and then, you know, 60 processes will then make up 1 request per second on average, and you know, a customer can have up to like hundreds of processes to like from 1 to 100, and that makes up for like an average of 30 processes per customer, and that's got to scale, right? So we've been trying to engineer an infrastructure that that can work for huge HTTP load, and we went with an approach called microservices. That means that we split up most of the stuff we have and then communicate over HTTP in between those services. And that is one part of the architecture that we wanted to scale. And also, the logo is, again, not really visible. But as many of the cool startups back in the day, we went with Heroku because we wanted to spare some of the costs of maintaining infrastructure, and also well, yeah, it's just the infrastructure, really, and that we wanted to cut a few dollars at. And then if you want to use microservice architecture with Heroku, you're just going to end up like this, because you have to solve one thing, and that's authentication. Because Heroku, you don't have VPN, so you don't have private networking. And then if you want to call like in between these services, you want to communicate securely, then it's going to be just a real pain. We went with HTTP signatures. We tried a few other things, and what we did at the end is that you take the body, you take the parameters, you take the headers, and then you sign it with a key. And what we've noticed from after some time is that these signatures were really, really slow to validate. But you can say that, well, of course you've been doing crypto, and crypto in most languages really suck because it's going to be really slow. You know, it's fine because you only do it once a request, you know, right? So we've been doing crypto these signatures, and we've noticed that our RPS just was like that, because it's just going down. And we figured that it's not actually the crypto that is slowing it down, but the URL parsing. We have a URL parser expert over here, and well, he knows how slow it is and how it is a really complex task, actually, to get to know how these things work. And they have a really, really long specification that I really wanted to read it through, but it had so many external links that it was like, no, I couldn't do it. So let's look on the internet for some already existing solution, and I found Google URL. Oh my God, this is going to be so awesome. I'm just going to use this C++ library over here, and then, you know, just use the N API, which is a C++ thing that binds to V8 and it abstracts away V8. You probably know, if you've ever worked with C++, you probably know this comic. How to learn C++ in 21 days. And at the end, it's like you just got to time travel, go back and kill your younger self. So, well, C++ is complicated, and I have never received any formal education on C or C++. So even that, I bought the book, you know, and I was, Yeah. So I tried to compile it. I just got stuck somehow in the washing machine. It didn't work out so well. So yeah, I expected to skyrocket, and then I just like, no, it's not the thing. There should be something that is fast and safe. I know something that's really fast. This is a Kawasaki Ninja H2, which goes at like 300 kilometers per hour. And then I know something that's safe, which is 2017 Toyota Corolla, which was the safest car in 2017. But I know one thing that is also fast and safe, and that is Rust. So I ended up using this. Rust, you know, probably it's a systems programming language that aims to be safe, concurrent, fast. Just use Rust. We have multiple ways, actually, to call from Node.js to call into Rust that we're going to see today. One of them being is a foreign function interface, which is like a common, it's a common interface to like, it's a common thing to use to interface in between the languages, and it's quite low level, but it can be used in multiple platforms. So it's not only for Node.js. If you write a module that exposes its functions to an FFI, then you can call it from Python or any other language. Yeah, and but there's more serialization that we have to do if we use this. There's another really cool project that I'm going to show in today's demo, and it's called Neon. And what Neon does is it abstracts away V8 types that we can use from Node.js, and then it integrates much better. So it is Rust code that we write that integrates much better with the V8 types that we are used to using in Node.js. Much tighter integration, and let's hop into some demo. What we have over here is the FFI library. We've seen some of these things today already. Is it visible? Yeah, yeah. There's a presentation mode somewhere. Yay. Yay. We have to use a no mangle for it to keep the names and stuff like that. And then we have to, if you look at the top, we have to use the libc crate, which has a few things so it is used to access C types, like over there, and then we can just parse, so we get like a car pointer over there, and we can craft a C string but we have to wrap it into an unsafe block because it's we're using raw pointers over there, which can be like shaky at times. And there's the URL module from the servo team, and then it is a super cool and super fast URL parser that I've picked to demonstrate this. And we can expose, so we just return a new C string, and we can get on with that. There is some other thing. Yeah. So this is the Rust part, and to access it from Node.js, we can just use the FFI package, and we have to give it the compiled binaries path, and then we have to give it the name of the function that we would like to call, and the parameters it takes, and what it returns. And then we can just expose it as any other node module that we would do otherwise. So this was the FFI part, and you can see if we go back to the implementation that there's quite some serialization that we have to do over here. And if we check the Neon part, Neon actually has a really good CLI tool that you can just npm install, and then it generates the project structure for you, and also like it has its own build command that we can use. And if we look into the native folder over here, we have the source file, and then instead of us having to do any kind of serialization, we can just use V8 types directly, and we can craft V8 JS strings, and we don't have to implement every. So in JavaScript, we're used to having like functions that take any kind of arguments, and if you look into this one, this function takes a call, which is if you have done any kind of programming in V8, this is kind of the same thing. We can access the scope, and then we can get the arguments, which is kind of shaky over there, but it works. And at the end, we can just return a JavaScript string, and it's going to work from the node side. And the only thing we have to do over here is to go into each of the, I already went ahead and done it, but so Neon, and then Neon build. So we don't have to worry about configuration, and this was a real selling point for me, because I'm not used to like lower level languages. I've been working with Node.js for 3 years now, and for me, this whole C++ and like the compilers and stuff like that, they were super scary, and I know for a lot of people they are. And this Neon project had like a CLI tool that generated everything for me, and I didn't have to worry about actually learning all those bits and pieces. I could just hop in, write some Rust code, call it from Node.js, and I was done with it. So if we go back one directory up, I've created this small script that we can test. Oh, I haven't shown the real benchmarking that I did. So I'm just generating, I have a script to generate a few hundreds, or, well, it's configurable, but there are a few, center presenter mode again. I have a few URLs to generate, and then I can run all the test functions on that. And I try it just once, but you can set the try count to, you can increase that so it parses the same over and over again. We're going to see why that is important. I'm just requiring it as if you have ever written Node.js code, you can already see that this integrates really well with it. And what I was thinking about is just setting up a build pipeline that I could create a wrapper around Rust URL and then just publish it to npm so anyone can use it if they want. So they are just exposed as small node.js modules, and then I'm benchmarking and running it a few times to see how fast they run. If I try to run it with, I can run it with just a single URL. You can see that the native, this is the time it takes for them to parse it, and then the native URL parse was actually the native, I mean it is the one that's built into Node.js, and the Rust FFI one took a bit longer than Neon. It's mostly because of the serialization of those strings that we had to do. And if I try to increase it, we can see that as we go up in the numbers, the native URL parse is actually getting the fastest because of the V8 JIT that it's going on. So there are a bunch of optimizations that we can do, and we have to pick the right tool for the right job that we have. But as you see, the Rust, well, those parts are not optimized by the Java, the V8 JIT, but we can do other optimizations on the Rust side if we want to. So what I wanted to say about all these things, well, here's the average time it took us to parse. As we went up, V8 actually won, but it's not a, it was just a demonstration of things that we can do. There are other ways to optimize this. But what I wanted to say is that Rust brings new opportunities. It opens new windows that, that we can use to optimize our existing code bases. And it allows anyone to leverage these new opportunities, because before we've had Rust, we've had to go through and kill ourselves from the future just to learn C++. But right now we have this a lot more approachable language without those build tools, without that steep learning curve. And I think this, right now, it allowed me to, someone without higher level C++ knowledge to dig down to that level and do some weird optimizations, which was really cool. And I also had fun. So I encourage everyone to try Rust, because if I can Rust, so can you. And thank you.
Are there any questions?
Oh, plenty. Have you checked the libs performance from Rust? So without the Node.js thing?
No. Well, which lib?
Here, so
Which lib's performance?
the Rust URL.
No. But we have a developer here that we might be able to ask if you have any questions.
It depends. So it's actually slower than the thing we have in Firefox now, but it has lots of room for optimization, and we know where. So it could be just as fast, or if not faster than the recommendations. Yeah.
Which is super cool.
So I'm just curious, why exactly is the Neon URL parser faster than the FFI one? Is it because it gets the return value from the scope and it doesn't have to allocate, or am I misunderstanding this?
I'll be honest, I don't know, but I can guess. So I haven't done much research on these things. My guess is that so when you use the FFI layer, there's just gonna, well, let's approach it from the other side. If you use it from V8, I've written native modules with C++ before, and I know when you bind it to V8 scopes and then you allocate objects on that side, then it's gonna be just much more integrated into the garbage collection and stuff like that. So it's just gonna be like more optimized that way. But I don't know why V8 cannot optimize these things, because it looked like even though it could optimize the native code, it couldn't optimize the one that hooks into V8. So maybe that's like not even true, but I think it's because of actually using V8's API and not the FFI layer.
Okay, thank you.
Anybody? Any more questions? Okay. Thank you so much for Peter for presenting and all our presenters. I think we can give it up for them one last time.